The next topic that we are going to deal with is the Quine-McClusky method. Solving problems with K-maps might not always be easy, especially when you take more than 5 variables or more than 4 variables. In this case, Quine-McClusky method is a much more systematic method to come to a minimal solution. In the Quine-McClusky method, you will be given minterms, just like in the previous case scenarios. Using the minterms, you need to determine all the prime implicants, and then finally you are going to use a prime implicant chart to select minimal set of prime implicants. To understand how this method works, we have to take an example. You're given the expression for f as minterms 0, 1, 2, 5, 6, 7, 8, 9, 10, and 14. The first step in the Quine-McClusky method is to form columns. So this is column 1. In column 1, I'm going to form groups. The first group is group 0. In group 0, you will have all the minterms that have 0 number of ones. In this case, only minterm 0 has 0 number of ones, which is basically 0, 0, 0, 0. Next, we go for group 1. Group 1 consists of all the minterms which have exactly 1, 1 in its minterm expansion. So in this case, we have minterm 1, minterm 2, and minterm 8. So just look at the minterms that you are given here and put them here on the left hand side or in column 1. 1 is nothing but 0, 0, 0, 1. 2 is 0, 0, 1, 0. And 8 is 1, 0, 0, 0. Next, go for group 2. Group 2 will have minterms which have exactly 2 ones. In this case, the minterms which have 2 ones are 5, 6, 9, and 10. So write them down here. 5, 6, 9, 10. 5 is 0, 1, 0, 1. 6 is 0, 1, 1, 0. 9 is 1, 0, 0, 1. And 10 is 1, 0, 1, 0. Finally, you have group 3, which consists of 3 ones. And the minterms are 7 and 14. So write down 7, 14. 7 is 0, 1, 1. 14 is 1, 1, 0. That completes column 1. Now we go for column 2. In column 2, we are going to compare the minterms in adjacent groups. We only combine the minterms if there is a 1-bit difference. So in this case, we are going to compare minterm 0 with minterms 1, 2, and 8. Now compare 0 and 1. You see that there is only a 1-bit difference, that is in the LSB. So here we write 0, 1, and we write 0, 0, 0, dash. The reason we are putting a dash is because only the LSB place is differing. That is, a 1-bit change is occurring at the LSB. So we put a dash, and then we put a check mark. Now we compare 0 with 2. Again, there is a 1-bit change, so we can combine them. 0, 0, dash 0. Put a check. Compare 0 with 8. There is a 1-bit change in the MSB. Therefore, you have dash 0, 0, 0. Put a check. This completes comparison between group 0 and group 1. Remember, we are going to compare adjacent groups. Now, the next thing is we need to compare group 1 with group 2. Now, can you combine 1 and 5? You can combine 1 and 5 because only one bit is changing. So I'm going to write 1 comma 5 0 dash 0 1. So if you look at 1 and 5, from the MSB, the second bit is changing. So that's why we have a dash in that place. Check 5. Can you combine 1 and 6? You cannot combine 1 and 6 because there are two bits changing. Can you combine 1 and 9? Yes, 1 and 9 can be combined, and there is only a 1 bit shift, 1 bit change. Put a check. Can you combine 1 and 10? No, because there are two bits changing. Now we move for minterm 2. We are going to compare 2 with 5, 6, 9, and 10. Can you combine 2 and 6? Yes. There is only a 1 bit change, 0 dash 1 0. Put a check on 6. Next, can you combine 2 and 9? No, there are 2 bits changing. 2 and 10? Yes. There is only a 1 bit change, dash 0 1 0. Now we go for 8. We cannot combine 8 and 5 because 2 bits are changing. 8 and 6 is also not possible. 8 and 9 is possible. We have 1 0 0 dash. Finally, 8 and 10 is also possible. So we have 1 0 dash 0. Completes the next group. Now we are going to compare group 2 with group 3. So compare 5 with 7. 5 and 7 can be combined because only one bit is changing, which is 0 1 dash 1. 5 doesn't combine with 14. Next, go for 6. 6 can go with 7. You have a 1 bit change, which is 0 1 1 dash. Can you go for 6 and 14? Yes. 6 and 14 would be dash 1 1 0. Can you combine? I forgot to put checks on 10, 7, and 14. Now, can you go for 9 and 7? No, because there are 3 bits changing. 9 and 14? No. How about 10 and 7? No. 10 and 14? Yes. So that would be 1 dash 1 0. This completes column 2. We go for column 3. Observe this more closely. Column 2 has, or the first group in column 2 has 0 number of ones. The second group has exactly 1 1. And the third group has 2 ones. In column 3, we are pretty much going to do the same thing as we did for column 2. Compare the adjacent groups and only pair them up if there is a 1 bit change. The other rule is even the dashes have to match up. Let's try to find out which ones can be combined. So 0 1, it has a dash on the right hand side. So look for a combination which has a dash on the right hand side. So that's 8 9. Can it be combined? Yes, it can be combined. 0 1 8 9, and it would be dash 0 0 dash. Put a check. You cannot compare it with anything else because the dashes have to align as well. So we are done with 0 1. We go for 0 2. Look for a dash, and you can see a dash in the same place with the pairing 8 10. And in fact, you can combine 0 2 with 8 10. So that would be dash 0 dash 0. So put a check. Can you combine 0 8 with something else? Form a pair between 0 8 and 1 9. So 0819, which is this and this. There is a 1-bit change and the dashes are aligning as well. But if you notice more closely, 0819 is nothing but 0189, which is same as this one here. So we can basically ignore this. Similarly, can you compare 08 with something else? You can actually combine 08 and 210 because the dashes align up and only 1 bit is changing. But if you observe this, 08210 is nothing but 02810, which is this one here. Therefore, we can ignore that. But make sure that you put a check mark. So that is all with the first group. Now let's compare group 2 and group 3 in column 2. 1 and 5, can you combine it with something else? So 1 and 5 has a dash in the second place, and you can only compare it with 10 and 14, but there's a 2-bit change, so you cannot really combine them. How about 1 and 9? 1 and 9 can it be combined with 6 and 14? You cannot do that because there is a 2-bit change, even though the dashes align. Next, go for 2, 6. Can you combine 2, 6 with something else? The only possible thing that you can do is 10, 14. And yes, you can indeed combine it because only 1 bit is changing. So 2, 6, 10, 14 would be dash dash 1, 0. So put a check on both these. Next, can you combine 210 with something else? The only possible thing that you can possibly compare is 614, and yes, they can be grouped up because only 1 bit is changing. So 2, 10, 6, 14. But if you notice that 2, 6, 10, 14 and 2, 10, 6, 14 are the same, so you can ignore this. But make sure you put a check mark. Next, can you combine 8, 9 with something? The only possible thing is with 6, 7 because the dashes align, but you cannot really combine them because 3 bits are changing in fact. And how about 8, 10? You could only possibly compare it with 5, 7, but again there is a 3-bit change, so you cannot really compare it. Therefore, we are done with all the comparisons. Now you can actually go for column 4, but if you notice it, column 3 and column 4 are never going to match up. Therefore, we are done with the table format, or we are done with the column ones. And the next step in the algorithm is discussed in another video.